All right, today we're going to pull back the curtain on how pretty much everything in our world gets built. We're going to demystify this incredible process of manufacturing, breaking down the journey from just raw stuff into the very things you and I use every single day.
I mean, seriously, have you ever actually stopped to think about it? It is so easy to take for granted. But every single object, from the phone in your hand to the chair you're sitting on, it started as something completely different. It's a story of transformation, and it all starts with an idea.
And really, that's what this all boils down to. At its very core, manufacturing is just the super clever process of turning the basic stuff of our planet into the useful things that we all rely on. It's a journey that really unfolds in four essential stages.
So, where do you even start? Well, our journey begins with the most fundamental choice of all, the material itself. You can't build anything without first deciding what you're gonna build it from. This one decision is the absolute foundation for any successful product.
Now, this statement seems kind of simple, right? But it is incredibly profound. I mean, you wouldn't build an airplane out of lead, would you? Of course not. The choice of material dictates literally everything that comes after. How strong the product is, how much it costs, how long it's going to last, and even the methods you can use to make it. For most products, it really comes down to a choice between two giant families, metals and plastics. On one hand, an engineer might pick a metal for its unbelievable strength and stiffness, perfect for something like a car frame. But on the other hand, they might go with a plastic because it's lightweight, it doesn't rust, and you can mold it into all kinds of complex shapes. It's always a game of trade-offs. Okay, so once you've picked your material, you have to give it a shape. And this is where the real magic of manufacturing starts to happen, turning a lump of raw stuff into a form that you can actually recognize. As complicated as manufacturing might seem, almost every single process for making a shape boils down to just one of three fundamental approaches. Think of them as the primary colors of making things. First up is casting. You can think of this as the melting method. You take your material, you heat it up till it's a liquid, you pour it into a mold, and then you just let it cool down and get hard. It is exactly like making ice cubes in a tray. You're creating the final shape from a liquid. Next is forming. This is the squeezing method. Here, you take a solid piece of material and use just immense force to press it or squeeze it into a new shape. Now, this works because of a cool property called plasticity, which is just the material's ability to be reshaped for good without cracking. A perfect example is extrusion. It's literally like squeezing toothpaste from a tube to make a long, continuous shape. And third, we have machining. This is the carving method. Here, you start with a bigger block of material and you just strategically cut away everything you don't want. It's almost like a sculptor carving a statue out of a block of marble. The final shape is what's left behind when you're done. So, you've picked your material, you've shaped all your parts, but very few things we use are actually made from just one single piece. So, the next big step is putting it all together. Just think about a car. It's not one giant piece of metal, right? It's an unbelievably complex assembly of thousands of individual parts, and each one of those was made using the methods we just talked about. Now, they all have to be joined together somehow. One of the most common ways to join metal parts is welding. It essentially melts the edges of two separate pieces and fuses them into one continuous part, creating a permanent, incredibly strong bond. Now, of course, there are tons of other ways, nuts and bolts, powerful glues, but welding is absolutely key for creating a single, solid thing from a bunch of different parts. We have our assembled product, but we are not done yet, not even close. The final stages are all about taking a functional product and turning it into a quality product. This is the quest for perfection. So how do you do that? How do you guarantee a product is a quality product? Well, it really comes down to two crucial things: protecting it from the world around it and making sure it was made right in the first place. This all starts with what we call finishing. Painting, for instance, isn't just about making it look nice. It is a critical first line of defense against rust and wear. Then you have even more advanced coatings. These are specialized layers that are carefully engineered to add incredible properties, like resisting super high heat or harsh chemicals. And that brings us to quality. The old way of doing things was to make a huge batch of parts and then inspect them at the very end, hoping you'd catch the bad ones. The problem with that? You've already wasted a ton of time and money making a defective part.
The modern and much, much better way is to prevent defects from ever happening at all. This leads us to this brilliant concept called poka-yoke, which is Japanese for mistake proofing. The idea is so simple but so powerful. Instead of just finding errors, you design the process so that making an error is basically impossible. Think about it. A system that flags a typo is just finding a defect. A poka-yoke system would be designed to physically prevent you from making that typo in the first place. It's about building quality right into the process itself. Okay, so we've gone all the way from raw material to a finished, quality-checked product. But the final, and honestly the most important lesson, isn't about any single one of these steps. Casting, forming, machining, welding, these are just the tools in the toolbox. The real genius of modern manufacturing, the thing that separates good companies from truly great ones, is how they arrange all these tools into a seamless, efficient, and intelligent system, where every single step flows perfectly into the next. And that brings us to the ultimate takeaway. It's not just about having the fanciest machines. The real secret is designing a system where everyone, from the engineer picking the material to the person applying that final coat of paint, understands their part in the whole process. That's the secret sauce. People and processes working together in perfect harmony. So take a look around you right now. That pen on your desk, your coffee mug, the laptop you're watching this on, they all have a story, a whole journey from stuff to thing, full of countless choices and incredible transformations. Which one will you never look at the same way again?